Hey, mathematicians. Happy Monday. Um, Hope you had a good weekend. Um, Mine was all right. And I guess we'll just go ahead and get started with today's lesson, which is on areas of circles and sectors. So a lot of this is going to be, at least the front side anyway, should be a review. You should already know how to find the area of a circle. It is pi times the radius squared. Um, so it's not too difficult. So we'll just do some examples. It says find the exact area and then the two decimal approximation. So you'll notice they give us a circle. The diameter is 14. So what does that mean the radius is? It would be 7, because remember the radius is half the diameter. So for the exact area, we plug it into that formula. Area of a circle is pi r squared. So that would be pi times 7 squared. And then if we put that in the correct order, that would be 49 pi. For a two decimal approximation, that sounds to me like we should be using the pi button on our calculator instead of just the 3.14. So I will do 49 pi. Oh, I missed it. Pi. Oh my goodness. Where's my pi button? There it is. Okay. Oops. Okay. 49 pi. There we go. Sorry, technical difficulties. Glare rounded to the nearest two decimal places is going to be 153.94. So that's approximately 153.94. All right. Second one, exact same. They give you a diameter. So you say the radius is 5, plug it into the formula. So that's going to be pi times 5 squared. So that's going to be 25 pi for an exact answer. And then a two decimal approximation, we'll plug that in to our calculator. 25 pi, 78.54 when rounded. Awesome. So that's how you do that. If you're looking instead, like on the next little column there, they give us the area. They say if this is the area, find the radius and then the two decimal approximation for it. So again, same thing. We're going to start with the area formula. Area is pi r squared. So if area is 83, we can plug in 83 for the A, and then we need to just solve that for R. So what would you do first? You would, I'm going to probably rewrite this as pi r squared equals 83. So if I want to get the R by itself, the first thing that you're going to do is divide that by pi. So that gives you r squared equals 83 over pi. And then to get r by itself, you would take the square root of that. So square root and square cancel each other out. And it looks like the exact answer is the square root of 83 over pi. Which, I mean, that's not very helpful. Like, what does that even mean? I don't know. But the two decimal approximation will. So we'll type that one in. So it's the square root of 83 divided by pi. Close that parenthesis. It's about 5.14 for a radius. So that's how you do a problem like that. I'll show you it again here on this second example. So again, start with the formula. A equals pi r squared. Plug in what you know. You know the area is 117. I like the variable that I'm solving for to be on the left, so I'm going to switch it around. Divide by pi, and r squared equals 117 divided by pi. And then take the square root of each side, and it would be the square root of 117 divided by pi. And then just take out your calculator and type that in. Rounded to the nearest 2 decimal places is still going to be 6.1. You don't have to put the 0 at the end. All right, a couple more word type problems. It says a tree has a girth, which is the circumference, of 150 inches. Find the area of a slice of the tree. Okay, so to find the area, what do we need to know? We need to know the radius, but they give us the circumference. So circumference, you should remember, is 2 pi r. So with this formula, we can find the area by plugging in what we know. 150 is the circumference. You would divide by 2, and pi r would equal 75. So the radius is 75 divided by pi. So I don't know if they want an exact answer or a rounded answer, so I will give both. So we'll start with, if this is my area, or my radius, to get the area, it's going to be pi times the radius squared. So that's going to be pi times 75 divided by pi squared. So if I square that, pull out my calculator again, it's going to be 75 squared, so that's going to be pi times 5625 over pi also squared, right? So we can simplify that. Remember, any whole number can be put over 1. One of these pi's can cancel each other out. So this pi will cancel with this extra pi, and that would be my area, my exact area, is 5,625 divided by pi, and then rounded to the nearest 2 decimal places, 5625 divided by pi gives you an area of 1790.49. So depending on what they ask you for, that's how you would do it. If they ask it in the decimal approximation, I wouldn't go through all the effort of keeping it as 75 divided by pi. Whenever I plug it into the area formula, I would go ahead and do that division and get that number. But I wouldn't quite round it there yet. I would keep it more than 2 decimal places just so that final answer is more exact. If you want to try that bottom one, you can. Pause the video, otherwise I'll go ahead and get started on it. So again, they give us the girth, which is the circumference. So it's 72 equals 2 pi r, divide by 2, and pi r would equal 36, which means your radius is 36 divided by pi. If you plug that into the area formula, that would be pi times 36 over pi squared. So this is where you pull out your calculator, because that's going to be a large number, 36 squared. So 1296. So my area equals pi over 1296 over also pi squared. And just like before, this will always be the case. One of those pi's will cancel with each other. And then, so there's my exact area, 1296 divided by pi. As a 2 decimal approximation, we'll type that one in, divided by pi. It'll be 412.53. So there you go, there's area of circles on the front. On the back, we start to find the area of sectors of circles. So that's going to be like a slice of the pizza, if you think of it as a pizza. So the area of the sector is pretty much the same. It's kind of like finding the length of an arc. You take the area of the circle and you multiply it by the central angle divided by 360. So not too hard. So I'll write that down because again this formula looks kind of hard. So it's the angle divided by 360 times the area of a circle. Okay, so if I'm looking at this, they say find the area of the sector and then also the 2 decimal approximation once again. Okay, so the angle is 72 divided by 360 times the area of the circle, which is pi, times the radius, which is 15 squared. So I'm just going to type in a lot of things here. First, what's 72 divided by 360? So that's 0.2. If you wanted to just reduce the fraction, that would be 1/5. 0.2 is fine also, but I'll write 1/5 times pi times 25. Oh, not 25. That's 15 squared, 225. Let me fix that. 1/5 times 225 pi. Okay, so what's 225 divided by 5? 45. So the exact area of that sector is 45 pi. The 2 decimal approximation, again, just type it in, 45 pi, 141.37. All right, let's do this one. A circle with a radius of 4 inches and a sector of 45 degrees. So again, angle divided by 360 times pi times the radius squared. So times 4 squared. Okay, so if we look at 45 divided by 360, you might have wondered, why did I change that to a fraction? Well, sometimes these decimals aren't going to come out as nice as these are, so you just leave it as the fraction. If you don't know how to change a decimal answer into a fraction in your calculator, just let me know and I'll show you how. Just hit me up on Google Hangouts or whatever, or just Google it and you can find it. Just type in the type of calculator you're using and how to turn a decimal into a fraction. So that's 1/8 as a fraction times pi times 16. So I'm going to do the 1/8 times 16 part. 16 divided by 8 is 2, so that comes out to be 2 pi for an exact area for that sector. And then 2 times pi is going to be 6.28 when rounded to the nearest 2 decimal places. And I mean, these are areas, so I guess I should be using my labels, but I haven't been. That's okay. The last thing you're going to find is the area of a segment of a circle. So a segment of a circle is the area. So if you just have like a normal chord, that's just a segment that's got its endpoints on the edge of a circle, not a diameter. So it's just some other kind of segment. The area of the segment is the little leftover shaded area of that circle. So to find the area of a segment, it takes a little bit of work. You have to find the area of the sector, then you have to subtract the area of the triangle that you would create with that sector, and that's going to leave over the area of that segment. So if you look at the picture, if you take that whole piece, you subtract that triangle, that's going to leave you with that little area there. So that's the process you have to do. So these ones take a little bit more work, but they're not too bad. So first thing we need to do is find the area of the sector of this circle. So again, that's going to be the central angle divided by 360 times pi times the radius squared. So 60 over 360 is going to reduce to 1/6. 18 squared is 324. And then it says to round this to the nearest tenth, so I'll go ahead and just type all of that in. 1/6 times pi times 324. Rounded to the nearest tenth is going to be 169.6. So this is my sector. 169.6. Okay, the triangle. So for this triangle, how do you find the area of a triangle? Well, remember, area of a triangle is base times height divided by 2. So for this triangle, I know the base is 18. What I don't know is the height. So this is a 30, 60, 90 triangle. I could use my shortcut here, but I want to show you how to do it if it's not one of those special right triangles. And to do that, you're going to focus on that triangle that you just created, right? So this is a 60-degree angle here. If the whole base is 18, that's going to leave you with 9 for the base of that triangle. What you need to know is the height of the triangle. So you're going to use a trig function there. And so you just look according to that angle, the height is going to be opposite, the base is going to be adjacent. So the trig function that you would use is tangent. Didn't quite give you enough room here, so I'm going to go up this margin. So the tangent of 60 equals the height over 9. So then if you solve that for h, it would be 9 tangents of 60. So we'll type that in, 9 tangents of 60. Yeah. So I will write down a few of those decimal places, 15.5884. 6. Okay, so now I go back to my original triangle. What's the whole base? The whole base is 18. The height is that number I just got, 15.8846 divided by 2, right? Okay, so I'll just type that one in. So 18 times 15.8846 divided by 2. So there's the area of my triangle rounded to the nearest tenth. That 6 is going to round that 9 up, which will bump it up to 143 even. So it's about 143. So I've got the area of the sector, I've got the area of the triangle. Now I just have to subtract the 2 to find the area of the segment. So a little bit more work, but not too bad. So what's 169.6 minus 143? That's going to be 56.6. And that's approximate. This one is actually very easy because it's a right angle. Since it's a right angle, you know that this side is also 4. So we really already have the base and the height of that triangle. So I'll show you how to do that. I won't need a trig function on this one, but I wanted to show you how to do a trig function one because I think there's one like that in your homework. So first thing, find the area of the sector. The sector is the central angle divided by 360 times the area, pi times the radius squared. So 90 over 360 is 1/4, and 4 squared is 16, and a fourth of 16 is 4 pi. So there is my sector. I'm going to leave it in terms of pi this time. Then the triangle is base times height divided by 2. The base and the height are both 4. That's going to be 16 divided by 2 is 8. So to find the area of the segment, I take the sector and subtract the area of the triangle. So I just will type that one in. 4 pi minus 8. Rounded to the nearest tenth. So this is my segment. Rounded to the nearest tenth is 4.6. Okay, so there's that. That's the toughest type of problem you'll see, just because it takes a little bit of work, but it's not hard. It's just, remembering your formulas and a little bit of trig functions. So let me know if you need any help with anything. Please reach out to me. If you do, I'll be happy to help. Just send me an email or Google Hangout at any time, and I'll get back to you pretty quickly. Talk to you later. Have a good Monday. See you later.